There is a specific type of engineering failure that is more dangerous than the kind that emerges from tests. It is the failure that only emerges from conditions that were not included in the test, conditions that the test was designed to validate against, and that the design of the test inadvertently excluded. The Boeing 737 MAX MCAS system was stress-tested extensively before it was certified. The safety analysis was thorough by the standards of the processes available. The aircraft flew millions of miles in simulation. Engineers modeled failure scenarios. The FAA certification process reviewed the documentation. In October 2018, Lion Air Flight 610 crashed. In March 2019, Ethiopian Airlines Flight 302 crashed. The same system, the same mechanism. 346 people died. The MCAS system had been tested. It had not been tested in the conditions that the crashes exposed. Those conditions were not exotic scenarios that no engineer could have imagined. They were the conditions produced by a sensor failure in an aircraft operated by pilots who had not been trained on MCAS because MCAS had not been fully disclosed to them. The plan survived every stress test because the stress tests were designed to evaluate the plan as intended to operate. The real test, the one that mattered, was operation by pilots who didn't know the system existed. Responding to a sensor failure, the system wasn't designed to handle redundantly in conditions that the certification documentation had classified at the wrong hazard level. The gap between the planned stress test and the real one was not a testing failure in any simple sense. It was a design choice about what the test was supposed to test that had been made in a context where the financial and timeline pressures of the certification process had shaped what was included in the evaluation. The MCAS system was added to the 737 MAX to compensate for a specific aerodynamic characteristic introduced by the new, larger engines. The engines were moved forward and higher on the wing for ground clearance, which changed how the aircraft behaved at high angles of attack. MCAS was the software solution. When sensors detected a high angle of attack, the system would automatically push the nose of the aircraft down. The key design decision, the one that the subsequent investigation identified as the specific point where the plan diverged from what the real test would reveal, was that MCAS relied on data from a single angle of attack sensor. Not two sensors cross-checked against each other. One sensor. If that sensor produced erroneous data, MCAS would activate based on a false reading. The safety analysis that was submitted to the FAA classified the failure mode of MCAS as hazardous rather than catastrophic. This classification matters enormously in the certification process. A catastrophic failure mode, one that could result in loss of the aircraft, requires substantially more rigorous design standards, including redundancy requirements. A single sensor architecture for a system classified as hazardous was certifiable. A single sensor architecture for a system classified as catastrophic would not have been without additional redundancy. The classification that allowed the single sensor architecture was the one that allowed the plan to pass the stress tests it was given. Have you ever been inside a planning or testing process where the classification of a risk determined what kind of testing was required, and where the classification itself might have been shaped by what the testing was expected to find? Leave a comment. The disclosure of MCAS to the airlines and pilots who would fly the aircraft was minimal. Boeing's position, which was accepted by the FAA during certification, was that MCAS would activate so rarely and its effects would be so subtle that specific pilot training was not required. Airlines that had 737 rated pilots would not need expensive new type ratings for the MAX. The training cost savings were part of Boeing's sales proposition. Airlines were choosing between the 737 MAX and the Airbus A321neo. The 737 MAX's training cost advantage, no new type rating required for existing 737 pilots, was a meaningful commercial differentiator. This commercial consideration shaped what disclosure was made, which shaped what training was provided, which shaped what the pilots knew when they encountered an MCAS activation. The pilots of Lion Air Flight 610 were not untrained. They were trained for an aircraft that was not the aircraft they were flying. MCAS existed. MCAS was capable of pushing the nose down repeatedly and with significant force. The pilots had no training on how to counter it because the existence of MCAS had not been communicated to them in a way that would have required training. The stress tests had tested the aircraft with pilots who knew what MCAS was. The real test was the aircraft in the hands of pilots who didn't. Those are different tests. The plan, the Boeing 737 MAX's safety case, survived the first kind of test. It failed the second kind catastrophically. If the specific mechanism, how the conditions excluded from the stress test were the conditions that determined the real outcome, is what makes this channel worth your time, the like is the direct signal. The 346 people who died in the two crashes were not killed by a technical failure in any simple sense. The MCAS system did what it was designed to do. The sensor failed. MCAS responded to the sensor data it received. The response was precisely the response MCAS was designed to produce. They were killed by the aggregate of design decisions made in a process shaped by commercial, timeline, and regulatory pressures. Decisions about sensor redundancy, hazard classification, pilot disclosure, and training requirements, each of which was individually defensible, and collectively produced an aircraft that could not be safely recovered from a specific sensor failure by pilots who had not been told the system existed. The congressional investigation that followed the crashes found that Boeing had internal knowledge of concerns about MCAS before the Lion Air crash. A 2016 internal message from a Boeing test pilot referred to the aircraft in terms that signaled significant concern about MCAS's behavior during testing. The message was not shared with the FAA. The concerns it reflected were not addressed before the aircraft entered service. The gap between what was known internally and what was shared externally, the gap between the internal stress test results and the information given to the regulatory process, is the specific governance failure at the center of this case. The practical lesson from the 737 MAX is about the relationship between the stress test and the reality it is supposed to represent. Any stress test, in engineering, in finance, in organizational planning, is only as useful as the quality of the assumptions embedded in its design. A stress test designed to validate a decision that has already been made will systematically exclude the scenarios that most challenge that decision. A stress test designed to find the failure modes of a decision will systematically include them. The question that distinguishes these two kinds of stress tests is simple to state and very difficult to answer honestly from inside a process where significant resources have already been committed. What are the conditions under which this plan would fail that we have not yet tested? For the MCAS system, the answer to that question, the conditions not tested, was operation by pilots who didn't know the system existed. Responding to a sensor failure, the system was designed to handle with single point of failure architecture. Those conditions were not exotic. They were real operating conditions that the commercial decision about training disclosure had created. The test that would have revealed this failure was available in 2017. It was not run. The test that was run tested what the aircraft could do when everything was operating as designed with pilots who knew what MCAS was. The real test arrived in October 2018. The next episode looks at a different kind of test failure, not the failure of the stress test to catch a design flaw, but the failure of the market test to signal what the competitive landscape would produce once the product was out. This content was developed with the support of artificial intelligence tools and underwent human review, editorial curation, and approval before publication. The analysis presented here is strictly educational and philosophical in nature, grounded in behavioral psychology and classical stoicism.